Christmas Eve 2024, NASA was doing something that scientists once called physically impossible. We are talking about the Parker Solar Probe, a spacecraft that flew directly into the atmosphere of the Sun, December 24, 2024. While the world celebrated, NASA was making history by launching a spacecraft the size of a car right into the Sun's atmosphere. The spacecraft was moving at an astounding 430,000 miles per hour. That's faster than anything we've ever built. Most people think the surface of the Sun is the most dangerous part, burning at 10,000 degrees Fahrenheit. But they would be wrong. The dangerous part is the corona, the Sun's outer atmosphere. This invisible envelope of superheated plasma is 300 times hotter than the surface below it. This is known as the coronal heating problem. The corona is also where the solar wind is born, a relentless stream of charged particles that hits Earth. Strong enough, it creates geomagnetic storms that can overwhelm power grids and satellites, costing trillions, like the 1859 Carrington event. How do you build a spacecraft that functions inside the atmosphere of a star? This was the engineering challenge that took decades to solve. During close passes, the heat shield faces temperatures hotter than lava, around 2,500 degrees Fahrenheit. Yet the instruments right behind it operate at a cool 85 degrees Fahrenheit. The secret is the thermal protection system, a 4.5-inch thick heat shield made of carbon-carbon composite surrounding a core of 97% air-filled carbon foam. This makes it an incredibly effective thermal insulator. Launching directly toward the Sun is impossible due to orbital velocity. The Parker Solar Probe took a long and complex route to reach its destination. Launched in 2018, the probe relied on a gravity assist technique, flying past Venus 7 times over 6 years. Each flyby bled off orbital speed, pulling the probe closer and closer to the Sun. During these orbits, scientists detected strange, zigzagging reversals in the Sun's magnetic field, nicknamed, quote, switchbacks, appearing in far greater numbers than predicted. The mission culminated in a planned moment of silence that tested the nerve of the entire team. On December 24, 2024, as the probe fell toward its closest approach, it entered a communications blackout zone, completely overwhelmed by the intense electromagnetic radiation. The machine went silent. After 2 agonizing days of waiting, on December 26th, the team received the beacon tone, confirming the spacecraft had survived and was fully operational. The room erupted in relief and celebration. When the science data arrived in early 2025, researchers had something they had never possessed before, a detailed view of the Sun's corona from the inside. The spacecraft captured footage of the solar wind being born, showing streams of charged plasma accelerating outward, making the entire dynamics of solar weather visible in real time. Preliminary data points toward those mysterious switchbacks, the zigzagging magnetic reversals, as a primary mechanism for transferring energy and heating the corona to millions of degrees, potentially solving an 80-year-old mystery. The data gathered is not just for science. It is critical for global infrastructure protection. Currently, we get mere minutes or hours of warning before a major solar storm. This data is the foundation for reliable early warning systems that could give us days of notice, protecting trillions of dollars of infrastructure and avoiding global blackouts. A human-built machine flew into the atmosphere of a star, survived, and returned data that is already rewriting textbooks. NASA reached the untouchable, protecting the civilization we have built.